G'day, I'm David. I'm a planner working with the TasWater CDO on the Launceston Sewage Improvement Project. As part of the Launceston project, we're doing a model calibration and hydraulic model build, and this project has been nominated for the AWA award. This is an essential project for TasWater to deliver asset knowledge and system reliability information around the Launceston sewage network, and importantly the Launceston combined sewage network.
Hey guys, I'm Manny and this is Hatham. We work for ADS Environmental Services. We're here in Launceston working on the TerHap project. Installing some flow gauges in the sewers and stormwater systems below the city.
My name is Gavin Woodburn. I'm a technical executive with WSP in the asset planning team. I've been working as part of the TasWater CDO on a suite of projects in Launceston since 2019. One of those projects is the design flow development and the model build and calibration that we're discussing. I did an interim measure where we validated models which improved upon the current flow regimes that we had within the catchment tools that we were already using. And then subsequent to that, we developed calibrated models that we're using as part of the design flow development for DBC. So it was really a two-stage process where we started and then improved upon our tools. And then once we've got our developed calibrated tools, we're then developing design flows through the use of applying climate change factors to future planning horizons. So for the catchment, we're using both design storms and we're using an RCP 4.5 equivalent series of design storms. And we're also looking at a 10-year time series worth of rainfall, which is not typically commonly used for assessing spill frequencies from the different thermal pump stations and treatment plants.
The main infrastructure around the combined system has been built over decades, and we've got a lot of infrastructure from the 60s through to around the 80s. We've got a reasonable idea of what it does, but we don't have detail on just how well it performs. So this is an opportunity to really get some good, accurate measurements of what's going on, which will really help us with our design, making sure that we sort of optimise it as best we can, and also give us a really good idea once we've completed the project of what benefits we've actually seen in what's going on.
So a perfect example of how the process is unrolled. As part of the SBC and early works for TerHap, we've come up with a range of design flows from one of the pump stations within the Tea Tree Bend catchment, which is going to take not only flows from Tea Tree Bend but also transfers from the Prospect Vale STP catchment. We had a series of assumptions and we've challenged those assumptions once we've got our calibrated models and identified that the assumptions that were made needed to be refined, and we're currently incorporating that into the DBC phase of this process, and that's also feeding into some of the design processes that the TerHap project team is using.
This information will provide comprehensive ongoing asset knowledge and system knowledge that TasWater can utilise as part of their ongoing daily operations, but also importantly for upcoming planning projects like LSIP and the TerHap project. These now calibrated catchment models are currently being used to develop future design flows for the LSIP project, incorporating growth and climate change factors and designing for the most likely future outcome. The project has also identified or been able to deliver unexpected benefits in terms of the amount of catchment knowledge that we've been able to obtain or infer from the flow monitoring survey has meant that we were able to identify suspected blockages and chokes within the system, and then we've been able to send out our service crews to address these chokes and improve the performance of the network in areas where we hadn't previously understood where there were restrictions or hydraulic constraints that have built up over time. And so ultimately this project will give TasWater the tools it needs to be able to deliver environmental improvements to the Tamar estuary and support the wellbeing of our customers into the future.